According to the Schrödinger theory, electrons of an atom are distributed into different orbitals. But there are very precise rules for the way electrons are distributed among the orbitals of an atom. These are: atomic orbitals are successively filled, starting with the orbitals of lowest energy. Each orbital can have a maximum of only 2 electrons with opposite spins. This is Pauli's exclusion principle. Among the generate orbitals, or orbitals of equal energy, each orbital is filled with 1 electron before any of them is filled with 2. This is Hund's rule of maximum multiplicity. Electrons that fill empty degenerate orbitals must have parallel spins. Let's try some examples to see how these rules are applied. For lithium with 3 electrons, following rule number 1, the electrons go into the orbital of lowest energy, the 1s orbital. Rule number 2 states that only 2 electrons can fill each orbital. Therefore, the first 2 electrons are in the 1s orbital. These electrons should also have opposite spins. To understand spin, try imagining that electrons spin clockwise or counterclockwise. This is not a physically accurate analogy. Nevertheless, it helps us to think about spin. To indicate electrons with opposite spin, we draw arrows pointing in opposite directions. After the 1s orbital has been filled, there is 1 electron remaining. This 3rd electron goes to the orbital of the next higher energy level, the 2s orbital. What happens when filling the degenerate orbitals, as with the p orbitals? In this case, we follow rule number 3. Each equivalent orbital is first filled with only 1 electron before any of them is filled with 2, or before pairing of electrons takes place. Take nitrogen with 7 electrons. Following rules number 1 and 2, 2 electrons go to 1s. Then, the next 2 electrons go to 2s. There are 3 electrons remaining. According to rule number 3, these will go to the 2px, 2py, and 2pz orbitals. 1 electron goes into each of these orbitals since they all have equal energy. They must all have parallel spins following rule number 4.